Thanks for joining us to this AWS Innovate 2017. My name is Jonathan Rold. I am leading the security practice for professional services here in APAC, China, and Japan. Today's talk is called Security and Compliance, First Steps to Best Practices. It's for you to have a strong foundation on how security works in the AWS cloud with lots of practical tips to do things securely. This is a level 200 talks. It is aimed to everybody, for developers and architects on how to design and implement secure systems, for security professionals to understand which of those security controls are proved to be the most effective in cloud environment, for management and executives so you can have an understanding on how your team should develop application for you or having oversight on the service provider you are working with. The goal of today's talk is in twofold. First, get you familiar with the best way to approach security and compliance with AWS. Second, learn AWS best practices across the 4 security areas up on the screen, starting with the story of somebody having a bad day and how you can have a great day. Let's get into it. For us, security is our #1 priority. It is not even close relative to anything else. It is the foundation on our business because our customers demand it and because we won't have a business if we don't do it well. Some people say it is the cloud, it's different, unusual, or something entirely new. Not true at all. Not through the lens of security we are looking. It encompasses very familiar pieces, physical security, network security, etc., that you use in your own on-premise environment. The only difference is we are often providing you a much better visibility, auditability, controls, and agility. The AWS infrastructure is custom built for the cloud, with all elements designed to intercommunicate well and present the smallest attack surface possible. In addition, the physical security controls present in our data centers has been designed to be the most stringent in the world. This pursuit has led to AWS being trusted by governments, military organizations, global banks, healthcare institutions, and other highly sensitivity organizations. Finally, our security team is monitoring the infrastructure all day, every day, and is well connected to all major security watchdog groups and vendors to ensure that potential threats are identified immediately. And the AWS security team is going this at massive scale, which is something that sets the AWS security organization apart. By looking after the AWS cloud, which have millions of active customers, each month running virtually every conceivable type of workload, we can see issues that may only occur once in a billion operations, multiple times a day. And because on how we are operating the AWS cloud infrastructure, when we remediate an issue or deliver new service, it benefits to all our customers at once. An important part of AWS platform is that security is a shared responsibility. Let's talk about how you can build on the AWS cloud and what you need to consider. AWS is doing the heavy lifting to let you focus on what is the most valuable to your business. AWS is responsible of the security of the cloud. We are taking care from the concrete of the data center and their physical security up to the hypervisor level. Every customer is running on the same platform. Whether it's Netflix or Commonwealth Bank of Australia, all our customers get access to the same level of security from AWS. It is quite likely for an online media company and a financial institution to have different security policies and requirements. So we enable them to implement their own security. Customers got to make decisions for the security in the cloud. For compliance requirements, you might require an additional layer of protection. You can impose additional controls such as encryption of data at rest or in transit, for example. This is done by leveraging AWS security services or use AWS technology partner that you are familiar with. We work in partnership with more than 1,000 independent software vendors through our AWS marketplace, including Chainpoint, Trend Micro, Splunk, Gemalto, and other security ISVs. Let me emphasize one more time. Understanding Who is responsible for what is critical for you and your organization to ensure your data stored and system running in AWS cloud are secure and accessible only by you. From time to time, customers ask us the following question: how can AWS give me confidence on how AWS is securing its part of the shared responsibility model? Here is 2 ways for you to do your due diligence and have confidence in AWS. The first point is we love to have customers telling us the experience. Take, for example, one of them said, and I quote, "The financial service industry attracts some of the worst cyber criminals. We work closely with AWS to develop a security model which we believe enables us to operate more securely in the public cloud than we can in our own data center." End of the quote. That person is Rob Alexander, the Chief Information Officer of Capital one of the largest banks in the US. The second confidence point is our assurance program. Let's dive into it. The AWS platform, region, and services are constantly audited by trusted third-party auditors. We are audited on our security controls and the way we manage risk in our environment. And when we say constantly, just for one of these boxes, let's say SOC, we are audited for just this one box every 6 months by a tier 1 audit firm. Those rigorous and independent audits are here to give our customer comfort. We do this because our customer cares, and we are constantly improving our security posture. The detailed assurance report for SOC, or as well PCI, are available under NDA for customer or potential customers, so you can use them as part of your ongoing security assessment. Now we covered how AWS does security and how we give assurance to our customers that we do it well. Let's talk about security services that you can leverage in order to run securely on your side of the shared responsibility model. So before we start, from where are those best practices coming from? We use 3 main sources for this talk, which are from customer on-the-ground experience, from recognized third-party expert, and as well from the AWS team. And I mean the team who are actually building and operating these services, the teams working day in, day out with large AWS customers, and the AWS security team itself. First, the AWS Cloud Adoption Framework, or CAF, is a distillation of the practical experience from both the AWS professional services and the thousands of customers we have worked with around the world. It connects the principle in the AWS well-architected program and turns them into a set of practical recommendations for achieving security in the cloud as an organization, and not only technical, but as well considering governance, security strategy, or policies and standards. It covers 10 areas with a special focus on what is called the core 5 epics shown here. The second source is the AWS Security Best Practices white paper. It uses categories found in the Cloud Adoption Framework and details 44 best practices covering identity and access management, logging and monitoring, infrastructure security, and data protection. These are AWS-specific recommendations for how to secure your workload running in the cloud. We will use these 4 categories as the structure to discuss the best practices we highlight today. Finally, the CIS benchmarks for AWS. If you don't know what the CIS is, the Center of Internet Security is a global community of experts that collect and endorse best practices for securing IT systems and data against common attack. They have released over 100 benchmarks from everything from Windows, Apache, Android, etc. In the last year, they released 2 benchmarks which are specific to AWS. The first, the Foundation benchmark, includes 52 specific checks for recommended security settings within any AWS environment, aligned to the category found in the AWS Security Best Practices white paper. The second benchmark covered a 3-tier web application built on AWS. It expands on the foundation benchmark and includes another 96 recommended security settings. Let's dive one slide deeper into CIS benchmarks. Each of the security recommendations includes details on what the recommendation is and some context about why the best practice was chosen. For example, here a recommendation to turn on AWS CloudTrail, AWS primary logging mechanism, in all 16 of our regions. This will provide an history of activity in all of the regions, which can help to detect unauthorized usage. Each of these recommendations also includes specific checks to verify if the control is implemented, as well as the recommendation steps with detailed instruction on how to fix each issue via the graphical AWS console or also via the command line interface. Overall, the CIS benchmarks are a step-by-step guide on how to configure and check 148 best practices for security in the cloud. All right, today's talk features two fellows, Anna and Bill. Anna implements AWS best practices in her environment and stays secure. She has a good day. Bill does not take the time to learn about best practices for security in the cloud, and he has a bad day. Bill runs a very simple 2-tier web application on AWS. For its web server, he has an Amazon Elastic Compute Cloud instance, or in short, EC2 instance. It is the AWS resizable virtual servers. Bill installed and configured the web server as part of his side of the shared responsibility model. The web server pulled its image to display from the AWS Object Storage Service, the Amazon Simple Storage Service, or S3 in short. The web instance also sent data in the internal data EC2 instance, which use a separate S3 buckets to store its backups. Bill's web application needs access from the public internet. And unfortunately for Bill, there is a bad person on the internet. This bad person finds a vulnerability in the web application that Bill chose to install and use it to access the operating system installed on the instance. Then looks at the application system and found credentials that give direct access to the data service. The credentials are in the config file, like is too often the case. The bad person decides to delete all the image of the website bucket and then change the permission in the data backup bucket, which lead to the worst part of Bill's day, because then the bad person downloads the entire data backup. How did this happen? Let's quickly look at what Bill got wrong. There is no application-specific security between the internet and the website itself. Inside the EC2, there is no segmentation between the network and the host that run the website versus the instance that run the data service. The entire environments run in one account. Bill granted full permission from his account to both S3 buckets. He stored sensitive data, in this case the data backup, in plain text. And finally, there is no logging, monitoring, or alerting running anywhere in the whole environment. In this situation, please don't be Bill. Now, let's see how Anna got it right. Before we talk about the best practices, let me explain the structures we will use to review all 12 best practices. The top is the title, and the icon relates to the AWS services that this best practice applies to. Under the icon is a summary text. I will not read that to you. It is a reference for you to dive deeper afterwards. The bottom shows if the best practices can be found in the AWS Best Practices white paper. Total spoiler, it's always will. And then It counts how many times this best practices is found in either the CIS Foundation or the CIS 3-tier web app benchmarks. So, the first best practice is to create a threat prevention layer using AWS Edge Service. The threat prevention layer inspects all traffic going through into your environment and is designed to provide additional security control like next-generation firewalling. Previously, we were recommending to build it inside your Amazon Virtual Private Cloud, or VPC. A VPC is a logically isolated section of the AWS cloud dedicated to you. Here, we are extending that concept to outside of the VPC to push away threats as much as possible from your data. This new threat prevention layer is based on our Edge services, which run in our global network of 76 locations worldwide. This layer is built on the top of our content delivery network service, Amazon CloudFront. It includes AWS Shield Standard, our protection service against DDoS, distributed denial of service, which is offered for free and activated by default. You can activate as well the AWS Web Application Firewall to enable scalable, application-specific protection for your web application. The second best practice is to create network zone using the virtual private clouds we were mentioned earlier and security groups. The security groups act as virtual firewalls for your instances. In our example, Anna used these to define separate zone of trust within her account. She can use these to write rules for traffic flowing into and out of her virtual networks, such as allowing only the database port into the database service backend and deny all outbound traffic initiated from her web tier to block any exfiltration of data. Remember, those two numbers at the bottom are how many specific examples of this best practice appear in the two CIS benchmarks. Creating VPCs and security groups is a popular recommendation which appears 35 times across both benchmarks. Our third best practice for infrastructure security is ensure you are managing operating systems and application vulnerability by scanning for missing patches and installing them promptly. Patching is critical, as we also lately with WannaCry. Patching is the key item that Bill missed when he installed the vulnerable web application that allows the bad person to get into his instance. Anna uses AWS automated security scanner called Amazon Inspector to check all our EC2 instances for vulnerabilities, both in the build stage and after, once they have been deployed. Anna knows that patching operating system and application is her responsibility in line with the shared responsibility model. Let's take a look at in the example architecture. What we see here is that Anna decided to bring in the combination of CloudFront, WAF, and Shield to give her some protection from internet-based attacks and some scalability. She chose to create segmentation using security groups and VPCs to provide separation and controls between her web servers and her internal data service. She also chose to turn on Amazon Inspector to provide that automated patching and vulnerability scanning. Our second category of best practices is data protection. In this context, it really relates to encryption. Our fourth best practices is to encrypt data at rest almost everywhere. We are recommended to encrypt the data you store on AWS. It is a good security hygiene. Encryption of data at rest provides you a number of benefits, including keeping them data safe from unauthorized eyes, because without the encryption key, this data is useless. Encryption allows Anna to protect her sensitive data, for example, her database backups, and gives access permission to only persons that should be able to access them. It means that anyone without the key cannot see this information. Note that Anna decided not to encrypt the image file in the S3, which are used in our public website because they are supposed to be viewed by everyone. Many customers choose not to encrypt public data. The next best practice is to take advantage of AWS Managed Encryption Service, or KMS, for AWS Key Management Service. Why? When you choose to use encryption, the largest availability risk to your data is losing your encryption keys. Because without that keys, this data is useless. AWS KMS is already integrated with a number of different AWS services, such as S3 and Amazon Elastic Block Storage, or EBS. Using KMS allows you to focus on what to encrypt and who should have access to the key and the data, and allows AWS to do the heavy lifting by focusing on keeping the service running and making sure your keys are available and highly secure. Anna chose to use KMS and chooses a key that AWS generates for her accounts, and click one box to enable encryption for the sensitive data in her data backup. Our 6 best practices relate to data in transit rather than data at rest. Encryption of data in transit keeps that data protected as it travels across virtual, private, and public networks. The industry as a whole has embraced ubiquitous encryption, especially defaulting to HTTPS websites whenever possible. Anna also wants to do this, so with few clicks she enabled TLS, or frequently referred as SSL. So looking at the architecture, Anna decided to turn on encryption in her S3 buckets. It is AOS 256, by the way. She decided to use 2 different encryption keys managed by AWS KMS and enforce different access policies. Then, for the protection of data in transit, Anna enabled HTTPS using TLS for her web servers to provide authenticity, privacy, and encryption for her customers. The next category is identity and access management. The number 7 out of 12 best practices is to add multiple AWS accounts. The benefits is to reduce the blast radius. How to separate, you may ask? We recommend you to do this by data sensitivity, separating the public data and the confidential data. As well, separate your non-production and production in 2 different accounts. And depending on your organization structure, each business unit can have their own accounts or set of accounts. We are making it easy to manage and operate through one of our service AWS organizations. In Bill's environment, the bad person was able to modify the S3 buckets configuration using the web server's access rights. But it's not something that the web server should be able to do. The next best practice is to limit the access through the use of least privilege. AWS provides multiple templates of rights for common roles seen in organization. For example, the network operator, the database admin, or the auditor. Note, you can custom build your own. IAM role. The beauty of IAM role is to allow access only through temporary credential, valid for minutes. And your application get access to those credentials securely from the metadata of your EC2 instances. It may sound complicated, but once you get your head around this innovative concept, it's really simple and powerful. It means that you don't need anymore to manage the credential in your code. And for the developers here today, it's integrated with our SDKs, so you don't even need to think about it. The next best practice is to use identity federation. The benefits of federation is to use a single identity store on-prem and in the cloud, using widely compatible SAML 2.0. You can use your on-prem directory to manage AWS access to start with, then you can decide to host the identity store in AWS to manage your hybrid environment. It provides a robust security for your users as they use the temporary credentials that we just talked about previously. So back to Anna's architecture. First, Anna decided to add an additional layer of separation between the web servers and the backend, which hosts highly sensitive data. Anna puts IAM roles on the instances. It's allowed to give the servers only the rights that it needs. For example, just reading this particular S3 buckets. Then, for the operation of the AWS environments, Anna will use federation to simplify the management, removing the need to create, update, remove AWS individual users' accounts. Last category is about logging and monitoring. This is so important. Bills may have a bad day without even realizing it. Maybe Bill had to wait that one of his customers call him and explain that his website has no image anymore. And even if now he realizes that he's having a bad day, he has nowhere where to go to understand exactly what is going on. The next best practice is to turn on logging and monitoring. And this, one of those things that's just take one click. For example, with CloudTrail, Bill would have known which user got his credential compromised and exactly when it's happened and from where it originated. And by the way, you want to turn it on in every region, service and accounts, because if you have no activity, it is free. But if something happens, you will have the logs. The second icon here is CloudWatch. It is providing real-time performance metric, as well as allowing you to consume logs from AWS and from your applications. Which brings the next best practice. When you log, you have the capability to monitor and alert when something goes unexpectedly. CloudWatch Alarm gives you the capability to define fine-grained monitoring triggers and generate a response, from sending an email to the on-call team to create an automated response like isolating a misbehaving instance. The other service highlighted here is AWS Config. It's continuously monitor and record your AWS resource configuration. It's allow you to automate evaluation of recorded configuration against a desired baseline and will flag any deviation. Auditors love it. The last best practices is to actually move the logs from the account, because you want to create a secure zone where you are confident that the logs have not been tampered with, modified, or deleted. The best is to create another AWS account where you can send all the logs and limit the access of the account to only persons that really need access, like for security analytics, for example. Back to the architecture. The service that we just talked about are really few clicks away. So Anna activates them and before a coffee gets cold. With those services, she's now able to monitor and trace back anything that's happened in her environment. For example, if someone deactivates the logging of CloudTrail, she has put an automation to turn it back on automatically. Overall, you can see that Anna is using way more services, but those are for a minimal cost. Anna has a really strong security posture because of those. And remember at the beginning of this section, the CIS benchmark provides the exact step-by-step process to enable them easily. I would like to close by recognizing that we are at the point of the industry where people and organizations have moved beyond asking, is the cloud secure? And people are now asking for practical advice on how to do things securely in the cloud. Well, these 12 best practices are the best way to be secure in the cloud. AWS has a number of security features and services that you can use. We have published our recommended best practices. The CIS has gone into specific details on how to enable those best practices step by step. All you need to do is just turn it on. It is easy to prepare yourself before it rains. Just grab your umbrella. It is easy to secure yourself in the cloud. AWS is doing the heavy lifting. All you need to do is just turn it on. Our call to action for you: download these 3 documents now, read them, send it to your coworkers, sit down with your team and review your environment and implement these best practices. As well, you can access this document at the resource centers on the main page of the AWS Innovate portal. AWS provides you what you need in order to be secure in the cloud. It is about you taking advantage of it. To close this talk, if after today you want to take your AWS knowledge to the next level, we are several options available to you. To gain more confidence and hands-on experience with AWS, watch our instructional videos and explore the self-paced labs. Additionally, you can attend our instructor-led classes by qualified AWS instructor and learn how to design, deploy, and operate highly available, cost-effective, and secure application on AWS. And finally, remember to validate your technical expertise with AWS certifications. Finally, I'd like to thank you for attending today and stick around until the end of this presentation. Your feedback is crucial to us to continue improving and to always deliver more value to you. And this is done through the survey, so please complete it. Thank you again for your time today.